Welcome back to the Deep Dive. Today, we're tackling, well, a really fascinating puzzle in physics, the gauge invariance problem.
It's fundamental.
Absolutely. It shapes how we understand light, matter,
Yeah.
the photon, specifically. But what if there was a way to just sidestep it?
Sidestep it entirely, yeah.
That's the claim of this EGM construct.
Yeah.
A different theoretical framework. It basically redefines some core ideas to avoid problems that, mainstream physics has been grappling with.
For a long time.
So our mission today is to unpack that. How does EGM shift things, and what could it mean for you and our view of the universe?
It's a big question.
Okay, let's set the scene. The standard picture, quantum electrodynamics QED, it treats the photon, the light particle, as massless.
Correct. Completely massless.
And that's not just like an observation, is it? It comes directly from this principle, gauge invariance.
Exactly. Gauge invariance is key. It ensures charge is conserved, our probability calculations actually work.
Right, unitarity.
Unitarity, and it keeps the math manageable. Renormalizability. It stops things from blowing up into infinities.
Okay, so that's the baseline. What's the problem then?
Well, the problem hits when you try to just give the photon mass within that QED framework.
You can't just stick it on.
Not without breaking things. You immediately violate gauge invariance. The whole structure starts to crumble.
And crumble how?
You lose charge conservation, which is fundamental. Your calculations suddenly explode with infinities. You can't get rid of non-renormalizable. And you even get weird stuff like impossible probabilities popping up because of an extra photon state, this sort of ghost polarization. It just doesn't work.
And we know the standard model can give mass to other particles, right? Like the W and Z bosons.
Yes, it does that very elegantly with the Higgs mechanism.
But not the photon.
No. For deep reasons within the standard model, the Higgs mechanism doesn't apply to the photon. It has to remain massless in that picture.
Which brings us to EGM's completely different route.
Exactly. EGM starts somewhere else entirely. It begins with an axiom, a fundamental assumption. Photons do have mass.
From the very beginning.
From the beginning. It's non-zero, inherent. Very, very tiny, mind you, but derived from EGM's own principles. And crucially, it fits within the experimental wiggle room allowed by the particle data group.
So the PDG doesn't absolutely rule out a tiny mass.
Precisely. They provide limits, and EGM claims its derived mass is consistent with those provisions.
So if the photon is born massive in EGM...
Then the whole problem of how it gets mass, the need for something like the Higgs mechanism, it vanishes.
It's not an issue because it was never massless to begin with in their theory.
Correct. It's a foundational input, not something acquired later through symmetry breaking.
That is a radical departure. And it tackles those infinities, too, you mentioned. The ultraviolet divergences.
Yes, and without the standard renormalization toolkit, EGM claims these infinities just don't arise in its framework.
How does it manage that?
It uses concepts like finite harmonic mode truncation and a quantum vacuum spectral limit, QVSL.
QVSL, what's that? Sort of like a cosmic speed limit for energy?
Kind of, yeah. It introduces a natural cap, an upper limit baked into the structure of the quantum vacuum itself. This is driven by what EGM calls energetic equilibrium. It inherently prevents those calculations from running away to infinity.
And it also rethinks the quantum vacuum itself.
It does. Instead of just empty space, EGM sees the vacuum as a polarizable medium, something active.
Like an ether, almost. But a quantum version?
Sort of, yes.
Oh.
A responsive substrate. And this view, they argue, helps unify quantum mechanics and general relativity. It offers potential answers to big cosmological headaches.
Such as?
Things like the many orders of magnitude problem, why theories predict vastly different values for cosmic constants, or the current Hubble tension, the disagreement about the universe's expansion rate.
And dark energy.
EGM proposes dark energy could actually be this field of massive photons permeating the universe. So yeah, it tries to connect a lot of dots.
Okay, but if it dishes gauge invariance, how does it ensure basic things like charge conservation are still respected?
EGM argues that conservation laws are intrinsically built into its structure. It points to something called the unit harmonic operator, the UHO.
Yeah.
Think of it as an internal governing principle, ensuring things like energy and charge are conserved automatically as part of the system's fundamental balance without needing that external symmetry principle.
So the proof is in the pudding,
Yeah.
essentially. Does it make testable predictions?
That's their big claim. EGM points to its purported empirical successes. predicting cosmological values like the Hubble constant, the background radiation temperature.
The CMBR temperature.
Yes, even claiming some predictions were made before data like the Planck satellite results came out. And also calculating particle sizes, like the proton and neutron charge radii, reportedly matching experiments very well.
Okay, but the standard physicist might push back, right? They'd say, look, massive photons without Higgs means broken gauge symmetry. How can it be consistent or renormalizable?
And EGM's response is quite bold. They essentially say that criticism is kind of irrelevant to their framework.
Irrelevant? How so?
Because EGM isn't trying to just tweak the standard model, it's proposing a paradigm shift. It argues the starting assumption of mainstream physics that photons must be strictly massless is itself a postulate, not an absolute empirical fact.
Because the experimental limits do allow for a tiny mass.
Exactly. So EGM says, look at our results. Look at the predictions, the explanations for cosmological puzzles, the derived particle radii.
So the argument is, if the theory works, predicts accurately, and describes reality consistently,
then that is its validation. That demonstrates its internal consistency and quantum validity. From the EGM perspective, the gauge invariance problem isn't something to be solved. It's a consequence of starting assumptions they believe are incorrect. Change the assumption, the problem disappears.
So wrapping this up, what's the takeaway for you listening? This is a fundamental challenge. EGM suggests that by changing one core idea, giving photons mass from the start, we might get a more unified, coherent picture of physics.
It suggests we might not need to fix problems that maybe only exist because of our initial assumptions.
It's not just avoiding a problem, EGM proponents would say, but offering a potentially more powerful, empirically grounded path towards unification.
A path that claims consistency and strong predictive power.
And here's a final thought to leave you with. If this EGM idea holds water, if photons are intrinsically massive, what other huge problems in physics, things that seem completely intractable now, might just dissolve when seen through this different foundational lens? Definitely something to think about.